section 3.1 is on angles and their measure. So we're going to talk about specific types of angles in this section. Before we do anything else, though, we have to define a few terms in geometry. So the first term we have here is line segment. You know what a line segment is? A lot of you, if I was to draw something like this and I asked you what that is, you'd probably say that's a line. You know, that's what people say in just general conversation. They say I drew a line. But mathematically, I didn't draw a line there. I drew a line segment. And the reason is because it stops here and it stops there. And we actually can draw it with those dots there to show it stopping at those spots. That's a piece of a line. But you know how long a line actually goes for? It actually goes forever. And so that's why in math, when you draw a line, you actually draw it with arrows on the end to show it continues on forever. Do you know what a ray is? A ray is like a combination of the two. It's where you have an end point, but then it goes on forever in one direction. Of course, I'm drawing everything horizontally here, but it could be in any direction, right? I could have a line that goes like this, or a line segment that goes like that, or a ray that goes like this, or whatever. So I'm just giving you examples over here, but they can certainly look a lot different than this. Okay, and so that brings us to an angle. The reason I introduced you to this concept of a ray is because an angle, one way to define an angle is it's determined by rotating a ray around its endpoint. And the endpoint is called a vertex. Okay, so what are we saying there? Now, you don't have this drawing, don't worry, I'm going to draw it on the other page, but it's just going to make it a little bit easier for me to show you something. So, first of all, here's a ray, and this is the end right here. This is called the endpoint or the vertex. Okay, and then this is like the starting ray, or another way you could say it, it's the initial ray. So this is actually called the initial ray or the initial side. Okay, initial means starting one. Now what I'm going to do is I'm going to draw another ray, and to tell the truth I've already drawn it, so there's another ray on here, and I'm going to rotate that ray around the vertex. So something like this, I'm going to rotate it, right, there's a second ray, and I'm just rotating it around the vertex. The vertex is staying exactly the same spot, and I'm just rotating this around. And okay, so again, it was down here, and I'm just rotating it around the vertex. Now, as I do that, no matter where I stop, whether it's there, or there, or there, or wherever, but I'll just put it here, where I stop, I end up with two things. One thing I end up with is, well, obviously another ray, and this is called the terminal ray. Terminal means like the ending, so this is the ending ray, or the terminal ray, or the terminal side, we'll call it. And between that, the two rays, we've now created an angle. And in this case, it's a positive angle. The reason it's a positive angle is because I rotated it, in this case I rotated it counterclockwise. If you're doing it counterclockwise, it's considered a positive angle. Okay? Just to give you another example of that, let's say that one ray started here, and that's my initial. It doesn't have to go straight out like this. Let's say this is the initial. And then I took another ray, and I start at exactly the same spot, so they're both at the initial side here, and I rotate, but this time I rotate it clockwise like this, and somewhere I stop. Let's say I stop right there. So just to label it again, this was the initial one, this was the initial side, this is the terminal, this is where we stop down here, terminal side. The vertex remained at the same spot the whole time. That's the vertex. And this time, in this case, we rotated this way in a clockwise direction, so this is a negative angle. Okay? That's basically what you need to understand here. So let me just redraw this very quickly for you over here. So one case we looked at was when we had two rays. One was the initial side, one was the terminal side. We rotated this way, we got our positive angle, and that was because we rotated it counterclockwise, and our vertex was right here, there. Then we had another case where we had something like this, sorry, just put some, these are rays, so I should put arrows on them. This was my initial side, and this time I rotated the second ray this way, so this was my terminal side down here. The vertex is exactly the same the whole way, and this was a negative angle this time because I rotated it clockwise. Okay? That takes us to this standard position. So what we're going to do now is we're going to take an angle and we're going to put it on a coordinate plane, right? This is a coordinate plane. You've seen this before. You name points. Don't draw this, but if I put a point right there, you'd name that 1, 2, 3, 4, 4, 3, right? And if I was naming the point down here, this is negative 6, 1. You know how to do that. At least you better. If not, I probably have some videos somewhere for you to watch. Now, what we're going to do is we're going to take an angle and we're going to throw it on the coordinate plane, but we're going to do it in a very particular way. We're going to take our initial side and we're going to put it out right along the x-axis like that. Okay, that's our initial side. So that's always going to be like that. In a standard position, an angle will have its initial side is along the positive x-axis. Along the positive x-axis. That makes sense why it's positive. If it's at a negative x-axis, it would go out this way in the negative numbers, but it's always going to be out in this direction. The vertex is always going to be right at this point. What's that vertex? What's that point called? It's the point 0, 0, and it's called the origin. So the vertex is at the origin. I should have said that first probably. The vertex is at the origin. The initial side is along the positive x-axis, and then we're going to take that second ray and we're going to rotate it around and we're going to end up somewhere. I don't know. Let's say I end up here. Okay, this is the terminal side right here. And depending how I got there, if I'd gone in this direction, rotated that ray that way, I would have a positive angle. But if, you might not want to draw this because it's going to get messy, but if I'd rotated all the way around in this direction, this would have been a negative angle. Okay, so this box area here, I've got some particularly important information for you there. So the first thing to do there is to remind you about the names of these different sections here, right? There's these 4 different sections. Do you remember what they're called? They're called quadrants. And they have really great names. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Very creative. And we almost always do it with Roman numerals. I have no explanation for that. Okay, the second thing I want to put in here is what angles, any angle in standard position, so that would be initial side here and terminal arm somewhere in here, whether it's there or there or there, wherever. Any one of those angles in that first quadrant, how much is the standard position angle? Well, it's going to be between 0 degrees and the biggest it could be is straight up, it would be 90 degrees. That would actually be outside quadrant 1, wouldn't it? But between 0 and 90 basically. Okay, in second quadrant it'd be from the 90 and it could be as big as, well, as big as all the way around to here, which is 180. In the third quadrant, so just so you know what I'm talking about standard position now angle with the terminal side somewhere down here in the third quadrant. What sort of angles would that be? That would be between 180 degrees and straight down here would be 270. So of course the last one here would be 270 degrees to 360. Okay, there's one last thing I'm going to write down here, but I'm going to save it. I'm going to come back to it in a little bit. Okay, so draw the following angles in standard position. First thing I'll do just very quickly here is I'll draw some coordinate planes. Okay, the first one, 100 degrees. Well, for all of these, we want them in standard position, so the terminal side has to go there. 100 degrees. Well, 90 degrees would be straight up, so we want a little bit more, so this would be 100 degrees around there. Is it exact? No, but it gives you a sense. This here is 100 degrees. 320. Terminal side goes, sorry, I think I might have said terminal side. Initial side. Both of these are initial sides. I'm sorry. I might have even said terminal side back here. Initial side, always along the positive x-axis. I apologize. Okay, so initial side along the positive x-axis, if it was straight up, it would be 90. If it was out here, it would be 180. If it was down here, it would be 270. If it was all the way around, it would be 360. Well, it's between 270 and 360, isn't it? Because it's 320. So, I don't know, it's 50 more than 270. It's about halfway approximately. So, this, all the way around here, is 320 degrees. Okay, negative 140. Still, the initial side is along here, but this time, since it's negative, we're not moving counterclockwise, we're moving clockwise. If we move this far, it'd be 90. We have to go another 50, so it'd be somewhere around here. This is negative 140 degrees. Last one, 600. Initial side goes here. If we were to go all the way around, we're only at 360. if we want another 180, 360 plus 180 is 540, and then we'd have to go another 60. So somewhere around there, approximately, is the angle, and so our terminal side would come like this, and this whole thing would be 600 degrees. Okay, now one thing that people often realize is, well, it's kind of weird to think of it going around all the way twice here. Why don't you just think of it going around once, like instead of going this crazy twirl like that, if we just went from there to there? This is obviously a related angle, right? And the reason it's related is because they both are in standard position and they both have the same terminal side. We have a name for that, and what we call that when two angles are in standard position and they have the same terminal side is they're coterminal. Angles in standard position have the same terminal side. So let's give you a little example of that. Coordinate plane, I'm going to draw an angle in standard position. There's the initial side. I'll put the terminal side up here, and let's just say, I'm just making this up, but let's just say this is 70 degrees. Okay, so 70 degrees is coterminal to, what could we make it coterminal to? Like, how could we make a coterminal angle? Basically, what could you do? Well, instead of stopping here, we could go all the way around and then stop there. That's coterminal. So how much is that? Well, that is the initial 70, but then we went all the way around, and all the way around is another 360, so 430 is coterminal. Well, we could extend this even further. We could go another time around. So in other words, we did another 360. 430 plus another 360 is 790 degrees, is also coterminal. How many times could we do this? Infinite. We could do another 360, another 360, another 360. So there's an infinite number of coterminal angles. But 70 degrees is coterminal to 430 degrees and 790 degrees. Add another 360 and another 360, and you'll get more and more and more. Okay, another way you could find coterminal angles for 70 degrees, so I'll just quickly redraw it. Standard position, terminal side, I'm calling this 70 degrees. What's another way we could do it? Well, instead of going all the way around like this, I could start here and go this way, and I get a coterminal angle, right? The definition is standard position. Yes, if I measure it this way, it's in standard position. There's the initial side, there's the terminal side, and they have the same terminal side, and they do. So how much is this angle? Well, the way I think of this is, if I'd gone all the way around, that would be 360. But I didn't go all the way around. How much less did I go? This amount. I didn't go 70. So if I take away the 70, I get 290 degrees. But remember, I went this direction. I went clockwise, so it's actually negative 290 degrees. Okay, once I know that this is negative 290 degrees, how can I get another coterminal angle? Go another way, all the way around again. So how much would that be? Well, that's negative 290, but then I'm taking away, since it's in this direction, the clockwise position, another full rotation, which is another 360, and so I get negative 650. If I wanted another one, take away another 360, another 360. So far we've found four angles that 70 is coterminal to: 430, 790, negative 290, and negative 650, and you could just keep going on and on and on with doing that. But I don't want to, so let's stop. Okay, coterminal angles are somewhat important. Reference angles are so important. You're going to use this so much in grade 11 and especially in grade 12. So you really want to make sure you get this year. Reference angles, it sounds kind of confusing. It says the positive acute angle that is formed with the terminal side of the standard position angle and the x-axis. Whoa, what are we talking about here? Alright, so again, I'm going to draw some coordinate planes, 4 of them again, for the 4 different quadrants. Okay, one possibility, I'm actually going to start with a second quadrant. One possibility is you have a standard position angle, there's the initial side, and the terminal side is in the second quadrant. And this is the standard position angle, right? I'm measuring it this way, it's positive. So that's the standard position angle, which we're calling theta. So this right here is theta. But what the reference angle is, it's the positive acute angle. You know what acute is? Acute is less than 90 degrees. The positive acute angle that is formed with the terminal side, well here's the terminal side, and the x-axis, well here's the x-axis. So in other words, the reference angle is this angle right there. This is your theta prime, which we're using to show the reference angle. That's the reference angle right there. Okay? Let's do a third quadrant example. So here's a standard position angle, terminal arm in the third quadrant. The standard position angle is this whole angle here, right? That's the standard position angle. But the reference angle is between the terminal arm right here and the x-axis. And remember, it's always acute. It's always less than 90, so you're not going all the way around here. That'd be more than 90. It's up like this. This is the reference angle right there. Okay, let's look at a fourth quadrant standard position angle, like this. The standard position angle is all the way around like that. It's very big. Where is the reference angle? It's between the terminal arm and the x-axis. This is the reference angle. Okay, let's go back to the first one. Confuses people when I do this one first, but when you do it last, I think you'll get it. It's pretty easy. It's too easy, because this is the standard position angle, and the reference angle is between the terminal arm. Whoops, I was doing this blue, wasn't I? Between the terminal arm, here's the terminal arm, and the x-axis. Don't go this way, that'd be more than 90 degrees. It has to be here. What do you see about the reference angle and the standard position angle? If it's in the first quadrant, they're exactly the same. Okay, I think we're ready to fill in the last piece of information on this graph right here. And what I want to look at is how you get the reference angles mathematically in each of the quadrants. So don't do this in yours, but I'm going to erase this, and I'm going to use this to give you some examples. So let's say that this is in the first quadrant, and let's say that it is 60 degrees. That's the standard position angle. What's the reference angle then? Well, remember what we just said? Standard position angle and reference angle in the first quadrant are exactly the same. So what we can say is that the reference angle, which we designate with theta prime, is actually just the same as theta. That's the standard position angle, right? They're equal to each other. Okay, not too interesting there. Let's extend this to the second quadrant. Get rid of this. Let's call this 120 degrees. Now, we just said from what we did in the other page that the reference angle would be this angle right here. How much is that? Well, you can probably just look at that and figure out that it's 60 degrees. So how did you do that? What you did to get the reference angle is you took a half circle, which is how much? 180, and you subtracted how much the standard position angle is, theta, right? The standard position angle is 120. 180 take away 120 is 60, and that's exactly what the reference angle is in this case. Great. Let's go to the third quadrant. Bring this down here. Let's call this 240 this time. So all the way around here is 240 degrees. Where's the reference angle? It's between the terminal side and the x-axis. It's right here. How much is that? Well, you can probably figure it out that from here to here is 180, so how much extra must there be in order to get up to 240? You need an extra 60. The reference angle is 60. But how are you going to do that mathematically without drawing it and stuff if you just have numbers? This one gets people confused. Often people think it has something to do with 270, but no, you never have 270 when you're using reference angles. You never use a 90 when you're doing reference angles. It's only 180 and 360. And basically what you do to get the reference angle in this case is you take the standard position angle and you subtract 180, right? If the standard position angle is 240, you take that and you subtract the 180 and you get 60, and that's what we said the reference angle is. Be careful with this one. I'm actually going to write down here not 270 minus the standard position angle in this quadrant here. Okay, that's what people often do by mistake. Okay, the last one, we'll get rid of all this. We'll move this to the fourth quadrant, like this. Let's say that it is 300 degrees. Okay, that's my standard position angle. So where's my reference angle? It's between the terminal side and the x-axis, so it's right there. How much is it? Well, if this is 300, how much do you need to go finish it off? You need 60. So how do we do that mathematically? To get the reference angle, we take 360 and subtract the standard position angle. Okay, there you go. Let's try a few of those. So the first one we have here is find the reference angle for the following. 220 degrees. So first of all, let's just think of this. 220 degrees. Where is that? Okay, standard position angle, 90, 180. This is 270, so it would have to be somewhere in here, right? It's in the third quadrant. This whole amount here is 220. We want to know the reference angle, which is right here. It's in the third quadrant. That was the tricky one. Remember, what you do to get the reference angle is you take the standard position angle, 220, and subtract 180. The reference angle is 40 degrees. Alright, 310. Now you don't have to draw them. In fact, it's better if you get to the point where you don't draw them. But just to make it clear, I'll draw them. 310, 90, 180, 270, 310 would be somewhere in here. So we want to know the reference angle, which is in here. Since it's in the fourth quadrant, to get the reference angle, you go 360, take away the standard position angle, so it's 50 degrees. Okay, negative 110. So this is a little different. It's a negative one, so it's not going to follow the rules I just gave you because it's a negative angle. So negative 90 would be here, so it's a little bit more. This is negative 110. So you could, if you want, figure out what the coterminal positive angle is and then just use our rule. But I think, if you really think of it, if this is negative 110 and we know that the reference angle is in here, how much more do you need in there to get all the way around the half circle? You need 70, so the reference angle is 70. I mean, sometimes it's easier just to draw your little sketch and to just think about it. 70 degrees, and it's positive. The reference angles are always positive. Even if it's a negative standard position angle, it still has a positive reference angle. Reference angles are always positive, and they're always between 0 and 90. Last one of these, 580 degrees. So, standard position angle, all the way around once would be 360. Halfway more would be another 180, would take me to 540. So it would be down here, and this is 580 degrees. And you have to figure out the reference angle. Well, it's in the third quadrant, first of all. But first of all, I think what I do is I turn it into the coterminal angle that just looks like this. Like, how much is that just from there? How would you figure that out? Well, if it's 580 going all the way around, but we're not going twice around, we're just going once directly to it, then it would be 580 minus the complete turn, which is 360, and you get 220 degrees. So that's how much this blue angle is right here. Now, we can use the rule that we used over here to figure out what the reference angle is right there. We do 220 minus 180 equals 40 degrees. Do you see it's actually the same question? It's kind of stupid, but 220 and 580 are actually coterminal angles, so I guess it makes sense they would have the same reference angle, doesn't it? Alright, last thing. Find all the positive angles less than 360 degrees that have a reference angle of 70. So now we're doing the opposite. In this one, I gave you the angle and I asked you to find the reference angle. In this case, I'm giving you the reference angle and I'm asking you to find all the angles that have that reference angle. How many are there going to be if it's less than 360? 4. It's going to be 1 in each quadrant. So here's a good time for me to introduce you to bow tie angles. You know me, I love ties, so let's draw bow tie angles. So basically what I'm saying here with bow tie angles is if you had a reference angle in the first quadrant, which is, let's just say it's 70 degrees, okay? There would also be a reference angle in the second quadrant that's also 70 degrees. There's also a reference angle in the third quadrant which is 70 degrees, and there's also a reference angle in the fourth quadrant which is 70 degrees. Do you see why it's called bow tie angles? Because we can make this nice bow tie. Man, I'd love to have that bow tie with 70 degrees, 70 degrees, 70 degrees, and 70 degrees. It's so cool. So if I want to know all the angles that have a reference angle of 70 degrees in the first quadrant, if these are all reference angles, how much is the standard position angle? Well, it's just the same, right? We said that about the first quadrant, is that the reference angle and standard position angle are both the same. So 70 degrees is one answer. In the second quadrant, so that's the angle that goes all the way to here, and then this is its reference angle. How much is that angle right there? How would you figure that out? Well, the whole half circle is 180, but you're not going that far. You're doing 70 less. So what you get is 110 degrees there. Okay, third quadrant would be all the way around to here. How are you going to figure out how much that is? A little tricky. We've got the half circle, but we have more than the half circle. Remember, we're not doing anything with 270. We've got the half circle, and we're going more than the half circle. How much more are you going than the half circle? You're going 70 more. So you're going to add 70 this time, and you get 250 degrees. And the last one, the fourth quadrant, all the way around to here, how much is that angle right there? Well, it's not all the way around, which would be 360. How much less is it? It's 70 less than that. 360 minus 70 is 290 degrees. So all of these four angles have a reference angle of 70 degrees. Okay, that was a lot of information coming at you pretty fast. Sorry about the length of this video. Enjoy your standard position angles.